Alrighty, so this is the sample calculation on page 101 of our notes book. We are specifically, to remind you, when you were looking in the question, it will be mentioning sodium carbonate hydrated, and the formula in the question will have this XH2O2, and you now then have to get in your head that the ending for the maths is going to be more than RW and more than the grams per litre calculation. So I'm not going to do the bulk of this calculation because I'm recording this between lessons. But what I will say is it's now really important in this that you are picking up the extra information that's in the question. So the blurb for the question will have something along the lines of, you weighed out 3.15 grams of sodium carbonate with water of crystallization attached, and you made that solution up to 250. Personally, at this point, I would always put it up into grams per litre. So that's multiplying this by 4 to give you 12.6 grams in a litre, and we will use that eventually. So when we do our titration maths, so when we do the W and we do our mass triangle, when we are done, we have found the concentration of just the Na2CO3, not of the water. And as we said in lesson, on a hot day, the water of crystallization may be more or will be less, apologies, because the water could have evaporated while you were having a chat before you made your solution. And on a really cold day, there'll be more water vapor from the air. So if we were to go down through all of this, when we would finish, our concentration in grams per litre that you would get should be 4.77 grams per 1,000 centimetres cubed. Okay, the two things that we normally have to find out are the percentage of water of crystallization is one of the pieces of blurb they look for. And the other thing that they will look for, and I know I've spelt that wrong, so apologies, is they will also look for what is the value of X. So I'm going to show you how I go about working out the different numbers that I'm interested in. So the first thing I do is I write out my formula and I put a big box around it, and that big box is this extra info down here. So that big box is telling me I have 12.6 grams in 1,000 centimetres cubed of the whole thing. For the Na2CO3, this is our titration value. So when we do the titration, we're only finding the sodium carbonate. So that is going to be 4.77 grams. And again, it's in 1,000 centimetres cubed. It is really important that you make sure that your units are the exact same. If they're not comparable, it's going to screw up your maths, and you're going to know it because it won't make sense when you go further down. But if you screwed it up and you can't recognize it, you just have to go with it. And as long as you're using your incorrect number correctly, it will be fine. So the last thing that I have to work out is the amount of water that's present. And that's really just a subtraction. So 12.6 take away 4.77. And when I do those things, I am going to get 7.83 grams again in 1,000 centimetre cubed. So we reiterate, my units have got to be the same for all three things. So just to help you out, this number is going to be given in the question in some format. As we've said, this is your W and your mass triangle, and the amount of water that's present is just going to be the difference between the two. So the question that they then will ask you is calculate the percentage of water of crystallization. And then it just becomes maths. So percentage of water is percentage of water over the total. So it'll become 7.83, and my total was 12.6. And I multiply that by 100 over 1. And when I do that, I should come out with 62.1%. Okay, so again, just to reiterate and make it clear, this is grams of water, and this is my total grams. That's how I work out my percentage water of crystallization. The value of X is a little, not more complicated because you've done the maths before. So to work out the value of x, we're going to use our empirical formula calculation. So in empirical formula, we turn grams or percentages, but we turn it into moles in the first instance, and then we divide by the smallest number. And remember, from your definition of empirical formula, it's the simplest whole number ratio. Okay, so this is my setup for this. Na2CO3, and it is going to be H2O on this side. We have to find the moles, and we know from our diagram here that we had 4.77 grams of sodium carbonate, and we know in terms of our water that we had 7.83 grams of water. So we're obviously going to divide by the molar mass of sodium carbonate, which you will have calculated earlier in your maths, but we'll just do it quickly. And again, I really recommend that you do it all out. 16 by 3, and that becomes 106. So today, just in lesson when students were doing it, gentleman never wrote that in, didn't recognize this, so was 23 marks, 23 units off his actual molar mass. So that's the advantage of writing it out like this, and as long as you put it into your calculator the same, then we're all good. Okay, H2O over here is going to be 1 by 2 and 16, which is 18. So we turn it into moles, like so. When I have done that, I should have 0.045 and 0.435. We've said our next step is divide by the smallest. So in this instance, it's in the 0.045 is the smallest, so that's going to give us our 1. And this is going to give me 9.66, which becomes 1:10. So x here is going to be 10. So our formula in reality was this. Okay, so it's the exact same as when we did empirical formula, except when we did it the first time around in our introduction to stoichiometry, we were doing it as elements. So we'd have a C, a H, and an O value. Now, we are now doing it over here with compounds, but the steps have not changed. Enjoy.